So for this particular question, we're going to calculate the sum to infinity for the sequence 48, 24, 12, and 6. Now, in your actual question, you won't actually know, it won't actually say to you, calculate the sum to infinity. What you need to figure out is how many terms you're being asked to find, and is there a particular rule where you can use the sum to infinity. So what we do is, first of all, we go through the normal process where we've got our T1, T2, T3, and T4. And we go through the process of dividing one by the other. So when we go T1 divided by T2, so if we go T2 divided by T1, in this case here, that's 24 divided by 48, divided by 48, that gets you 0.5. And if we go T3, which is 12 divided by 24, that, of course, also gives us 0.5, and so on. So that tells us that our R value is equal to 0.5. And there's a rule that you need to know, is that you can use the sum to infinity. So we go sum, and it's like a fallen over 8, sum to infinity, when your R value is between -1 and 1. So basically it's less than 1 and greater than -1. So when it's a decimal like 0.5 or -0.3 or 0.75 or something like that, you can use the sum to infinity. If the R value is greater than -1, like -2, -3, -4, etc., or if it's greater than 1, like 2, 3, 4, or whatever, you cannot use the sum to infinity. It just doesn't work. So the sum to infinity rule is quite simple, and you can find this on page 32 of your book. So the sum to infinity is equal to A, which is your first term, over 1 minus R. Simple as that. Now in this case here, we know that our R value is 0.5, our A is 48, and that's all we need. We don't need to know the number of terms because that's not important in this particular case. So if we substitute this in, the sum to infinity is equal to 48 over 1 minus 0.5, which is the same as saying 48 over 0.5, and that gives us 96. So the sum of these digits here, this particular sequence, will only get up to 96. And you're thinking, how's that happen? Well, as you get if we look at our sequence here, we go from 48, I'm just going to give you a bit of an explanation here. 48, 24, it's obviously halving each time, isn't it? So 6, 3, 1.5, 0.75, and so on. It's getting smaller and smaller and smaller and smaller. And that amount gets smaller and smaller that you get to the point where you're not actually adding anything else to your sum. So that's why we call it sum to infinity, because you can go on infinitely and it will never get more than 96. That's actually the upper boundary. That's rounded up. I mean, the most it'll ever get would be 95.9999999 and so on. But we can round it up to 96. So that's when the sum to infinity is used. So if you're given a question where you've got something unrealistic, but as the R value is between -1 and 1, then you can use the sum to infinity. Right, so what we'll do is we'll put this knowledge of sum to infinity into a question. So in this question here, we've got, in a zoo, a disease is spreading, and the vets are administering a new cure. In the first week, 500 creatures are cured, so that's our T1. In the second week, 400 are cured, so that's our T2. And in the third week, 320 are cured, so that's our T3. And by the way, that first one is also our A value, isn't it? If this rate is to continue, how many animals will be cured? So you'll notice here we haven't actually specified how many weeks. So that gives us also a bit of a clue as to that we're probably going to be using sum to infinity. So first of all, we know that our A value is equal to 500. There's been no n, so that gives us another clue to the sum to infinity. Now to work out our R, we have to go T2 divided by T3, so T2 divided by T3, so that's 400 equals 400 divided by 500, and if you do it on there on your calculator, that's 0.8. And if you do T3 divided by T2, so 320 divided by 400, you'll find that that's also equal to 0.8. So our R value is 0.8. So now we can plug that into our equation. The sum to infinity is equal to, and remembering our formula, is equal to A over 1 minus R. So the sum to infinity is equal to A, in this case is 500, over 1 minus 0.8. So I'll just do that over here. So the sum to infinity is equal to 500 over 0.2, which equals 2,500. So what we could say in a sentence, 2,500 animals would be cured. And that's how you work out their problem.